Hello guys, welcome back to Fun with Physics. How are you guys doing today? I hope you're cool. In today's lesson, we're going to be looking at high pressure and low pressure. We're going to look at cases where we have high pressure, which we also call maximum pressure, on a surface being exerted on a surface, and low pressure, which we also call minimum pressure, being exerted on a surface. Okay? Now, if you have your textbook, Complete Physics for Cambridge Secondary 1, can you turn to page 151? Okay, that's the area we're going to be concentrating more on. Okay, are you all there? Okay, that's good. Now, without wasting time, we'll move to what we have at hand. Now, look at this, what you have on your screen. Small and large pressure. Now, we have in our left hand side here this exerting a force, and then this exerting equal force. But look at the surface, the deformation, okay, the level of deformation in the surface. Which one is more deformed? I believe this, right? Okay, now why do you think that this one is more deformed? This one pierces through the surface more than this. Why do you think? Okay, I know some of you say because this has a high pressure, right? Okay, aside this, what you have on the screen there, why do you think this one pierces through the surface? Okay, because of the area in contact. The area in contact is small, while the area of this one in contact to the surface is wide, or is bigger, isn't it? Good. Now look at the case, another case where we have large and small pressure being exerted on the surface. Here the woman is standing, but here she's dancing with just a tool. Now what did you notice here about the deformation? You can see that the whole weight exerts more pressure here compared to this, right? And this is another case where somebody is hitting a nail, a stick guy is hitting a nail and this on a wall. Notice that this one is able to penetrate the wall, but this one did not. Okay, can you tell me the reason? You have an idea? Okay, because of the area, right? The area in contact with the surface is small, and so it pierces through. It has more pressure, it penetrates through, exerts more pressure to the wall, inside the wall, right? Good. Now we're going to decide the next case. Let's decide the case A and B, A or B. Okay, in which of the case would a large and small pressure be exerted on the surface? Well, let's see A and B here, and A and B here. I guess many of you are going to see B, there will be large pressure, and then A, there will be small pressure. Now, why do we have small pressure here? Can you guess? Any idea? Yeah, I guess some of you will look at the area here, see the area, how wider area in surface contacts lying through, so it has a small pressure being exerted here. But here, just the leg is standing, so have more pressure being exerted. I guess you know what to do, especially when you are in there in an ice, okay, that is capable of sinking, and then you want to rescue someone. You know what to do. Instead of walking on it, you can, you can lie flat, belly flat, okay, and crawl down to rescue the guy, right? Okay, now look at this case. This is the one I'm going to emphasize on, the case of a brick here, A and B. Which one are we going to have more pressure? More pressure, I mean maximum pressure on the surface. Okay, B, right? Yeah, in B we're going to have maximum pressure, but in A we're going to have minimum pressure, small pressure, because the area here in contact with the surface is bigger than this. Okay. Okay, to calculate large or maximum pressure, we need to divide the weight or force of the object in contact with the surface, okay, by the smallest area in contact with the surface. That's the area in contact. Now look at this brick. Okay, you may be tempted to say that the smallest area is 3 by 1. I mean 3 by 1 this side. Okay, but look at it critically. We have three areas here that we can get, right? The surfaces, surface area. We have three surface area we can calculate here. We have 2 by 1. That's this surface here. And we have 3 by 1. 3 times 1. That's the surface, isn't it? And we have a bigger surface here, this one, which is 2 by 3. Okay, so when you calculate it, I guess you're going to get 1 to be smallest. You're going to get 1 as the smallest area. Which one do you think? This one, right? 2 by 1, right? Okay, so for you to calculate, for you to find out the smallest or the highest pressure, you need to calculate the smallest area. So the smallest area is going to exert more pressure, okay? So here in this case we have pressure, force over area. We know this. The force here is 0.3, which is the weight of the block. Then the smallest area of the brick is the 2 by 1 section, the 2 by 1 section, which is 2 square centimeter. So the maximum or large pressure will be the force over the smallest area, okay? When you divide it, you're going to get 0.15 Newton per centimeter square. Okay, now notice that I did not use 2 by 3 as the area. I'm looking for what? The smallest, the largest pressure. Remember, the largest pressure is being exerted by what? The smallest area. Okay, so in other words, we can see pressure is inversely proportional to area. So when you decrease the area, you are increasing the pressure, isn't it? Okay, and directly proportional to the force. That is, when you increase the force, you'll be increasing the pressure. Okay, but in any of these cases, something must be kept or something must be controlled, right? Okay, let's look at the other case. We have here, if you want to calculate the small or minimum pressure, we need to divide the weight of force exerted by the largest area in contact with the surface. Now, in this case, we can check out the largest area. I think the largest area should be this 3 by 3 or 3 times 3, right? This side. Remember, this side is the same thing as this. This is a prism. Okay, rather, yes, of course, a prism, rectangular prism. You can also call it a cuboid, right? This side and this side is the same thing. The base, the top is the same thing. So this side and this other side is the same thing. This one and the other side by the side is the same thing. Okay, so the 3 by 3 section in contact with the surface will exert the smallest pressure, right? So for us to get the smallest pressure here, we need to get the force, which is also the weight, 0.72 Newton, on the largest area of the brick, 9 square centimeter, and then divide both of them. This divided by this, that is force over area, then get our answer, 0.08 Newton per centimeter square. Now guys, can you calculate in any case? In case I ask you to find the smallest pressure or the largest pressure being exerted by a solid shape like this, I hope you can do that. Okay, for instance, if I give you a brick and ask you which side is going to exert more pressure, can you find out the pressure it can exert? I believe you guys can. You know the dimension to use. You know that you have to use the one with the smallest area to get the highest pressure it can exert. And you use the sides with the largest area, the largest area of the brick, to get the smallest pressure it can exert. Okay, now look out for questions like this next time when we treat your workbook. Okay, we have a quick review. Now let's quickly review what we've learned, and then we'll move forward to have a brief exercise. Okay, now record the pressure is force over area. Remember the pressure is measured in Newton per meter square, also Newton per millimeter square, Newton per centimeter square, but this is a standard one, Newton per meter square. And remember that 1 Newton per meter square is the same thing as 1 Pascal. So if you don't want to use Newton per meter square, you can as well use Pascal. It's no problem, there's no harm there. They are equal, they are the same. A small force over a big area produces a small pressure, and a large force over a small area produces a big pressure. Okay, Now you can manipulate your formulas this way in case you are in a triangle, in case you are given different options to find. For instance, if you're asked to find the pressure, all you need to do is to cover it with your thumb and divide force over area, like we have here. In case you're asked to find the force, you cover it with your thumb and multiply pressure times area, okay? And in case you're asked to calculate the area, close it with your thumb, just like it's highlighted here, and you find force over pressure, okay? So it's a very simple case. You can always use that, all right? Now, the practice question, page 151 of your textbook. Guys, you've seen the review and you've seen some of the things we talked about. You're gonna employ the skills now to solve this problem, okay? You're going to employ the skills to solve the problem. Remember the skills I mentioned before, especially this triangle formula. You're going to employ it to solve a problem like this. And remember, in creating the triangle formula, I said the numerator of your formula will always be at the top, like the force here will always be at the top. Then this and this will multiply each other. Okay, the numerator of the fraction, like this force here, will always be at the top. Okay, so you can create it. It's not difficult for you to create. Now you can manipulate this to solve this practice question. I want you guys to try it. Okay, it's in page 151 of your textbook. So guys, try it and let me see what you can do. It's not graded. Just let's see what you can solve. I'm going to send the correction of your work. You're going to see it shortly. Okay, but let's see what you can do first. Try it. Then you're going to compare it with my correction letter and see if you're correct. And if you're not, if you're correct, thumb up to yourself, thumb up. And if you're having one or two mistakes, you can always look at my own corrections and quickly correct yourself, okay? You're not to forward it to me, please. All right? Now, exercises. Let's quickly solve this exercise and move on. We have this. Calculate the force exerted by gas of pressure 150 pascal, 150,000 pascal on an object of surface area 3 meters square. In this case, we have to look for force. From the triangle, you can see that force is pressure times area, okay? Or you can switch over. Pressure is force over area, so it becomes force pressure times area. So pressure multiplied by the area, that will give us the force we need. Is that understood? It's very simple. Okay, the next one is calculate the area that will exert a force of 6,000 Newton from a liquid exerting a pressure of 300 kilopascal. Okay, mind you, kilo means what? 1,000, right? But if I don't ask you to convert the units, there's no need for you to convert, just solve. Okay, but if you must convert, then a kilo means 1,000 of a pascal, okay? So in this case, we have this. We converted, we said 300 kilopascal, which is 300 times 1,000, that is 300,000 pascal. And then we divided 6,000 divided by this. Then we have our answer, okay? As the area we need. Remember that the area, you can always get this from your triangle formula. Okay? So the next one is a similar question. We have a question. This is a question that it's very, if you actually understood the concept of maximum and minimum pressure, this is just a simple question to you, but not to worry, we're going to solve together. Now here in this question we have a metal block. The metal block shown opposite, it's by the side, has a weight of 900,000 Newton. Calculate the maximum and minimum pressure it can exert when placed on its surface. Okay, so the maximum pressure it can exert, remember, will be from the smallest area. Maximum means the biggest, will be from the smallest area. So from this, what's going to be the smallest area? Is it 5 by 3? I don't think so. This is 15 centimeter square. It's 15 meters square. Is it 2 by 5? This is 10 meters square. I don't think so. But let's look at this side. Is it 3 by 2 by 2? 6 meters square. Yeah, I think that is the smallest area, right? So that's the smallest area we're going to use. Okay, now let's see the working. Maximum pressure when the block is placed in the smallest area, which is 2 by 3. Okay, so we use the formula pressure force over area, and then substitute our values. Make sure you substitute your value in the right place. The force should be at the top and the area below. Okay, then you can use your calculator or solve it offhand, or solve it by heart, and then write your answer. Okay, this is in Pascal. You can also leave it in Newton per meter square. Now for the minimum pressure, notice that when we try to get the area of each of these, we got this as the highest one. We got 3 5 by 3 by 5. The top or the bottom is 3 by 5, or 3 times 5. Okay, so 3 times 5 is the highest area of the surface in contact with the biggest area. So we are expecting it to give the smallest pressure. Okay, so that's it. So 15 meters square, the force divided by 15 meters square, that gives us the smallest pressure. Guys, do we understand this? I hope it's not it's easy and straightforward, right? Easy peasy, right? Very good. So in the next lesson, we are going to look at some of the effects of pressure. Okay, until then, bye.